Good evening, everyone. My name is Aynaz. I'm from American International School studying AP Physics that is hosted by Mr. Youssef. So me and Hamad Nadim, today we're going to explain you what is circular motion or uniform circular motion basically. Okay, so the objectives that we're gonna cover up today are first review of centripetal acceleration, then uniform circular motion on horizontal plane, which these two I'll be explaining. Then Hamad is gonna take over the uniform circular motion on vertical plane. Then last but not least is also to solve some problem solvings regarding this topic. Now, refresh up your memory. What is acceleration? Acceleration is basically, okay, let me just come up here. Acceleration is basically, as we know, lowercase a is written as lowercase a. So acceleration is basically a rate of change of velocity of an object due to the respect of time. Okay, so as we said, change of velocity. Now velocity depends on two things. It's a vector, right? So it depends on two things. First is direction, then magnitude, which is speed in another word. Now as we know, first let's assume a car is moving, okay, towards, let's say, right. Then suddenly at this point it decides to move backward. Okay, so as we know, it has velocity, it has acceleration. Now suddenly, and they're both trying to move in the same direction. Okay, then suddenly velocity is trying to move against the direction of acceleration. In here I'm not trying to say positive or negative directions at all. I'm just trying to say that when the velocity is against the direction of acceleration, the acceleration will start to decrease. In opposite way, if the velocity is in the direction of acceleration, of course the acceleration will increase. All right, as we see in here in the PPT, I have a picture explaining that. Now, something might come to your mind, something might link to your mind. What happens if we have a condition that, for example, we have a pin over here, and we have a rope, and we have like a paper, then it's moving in circular path, and it does not have any magnitude, which is speed, no change of velocity, no change of velocity. So what happens in here? Well, let me tell you something. As we said, the acceleration is depends on basically change of velocity, and velocity depends on two things: direction and magnitude. Now, if the magnitude is not changing over here in our example, then this might be the key. The direction is changing. As we can see in here, the only thing that is changing throughout the pass of time is only and only our direction. So we can conclude that there is the velocity, change of velocity, that is causing to create acceleration. But this time our acceleration is called centripetal acceleration. Why? Because it is let's say attached to a center of the circular path, that this force is somehow towards the center of the circular path. Now this force, later on we can discover more about it, but this force is called tension. Now this tension is the key of why this object is moving in circular path. It's not moving against it, because as we know, the object is already having a velocity or a force that is causing it to move, right? But this tension is trying to keep it in its own direction. All right, so if this gets cut, or if this rope if we cut this rope, what happened is that this object will probably fall in this way or like this. Yeah, because no more force is keeping it in this path. All right, let's get back to our presentation. All right, so what causes centripetal acceleration? Okay, as we know, if the force remains perpendicular to the velocity, it will always be pointing towards the center of the curved path, as I already explained that. So we can say that I can easily explain you that what do we mean by circular uniform circular motion? Basically, uniform meaning to say that the speed is in the same change throughout the curved path, and also circular motion is trying to say that the object is moving in circular motion with constant ratio. All right, so this is just an extra information to know what do we mean by centripetal acceleration, also to know the uniform circular motion. Okay, what causes centripetal acceleration? Well, it's just like any other acceleration. It will start from a point with a net force that is perpendicular to the surface, and which is Newton's second law, basically, as we have in here, F is equals to ma, but in a little bit more advanced way. Why? Because as we said, A is not any more regular acceleration, it's centripetal acceleration. Now, as we know, in another way, we can say that acceleration is v squared over r. Am I right? So we can say that instead of F, we can put AC, which is acceleration, centripetal acceleration. So centripetal acceleration, we can conclude that it's equals to v squared over r, which we also, when we have mass, it's also mv squared over r. Okay, now uniform circular motion on an horizontal plane. When an object has a constant velocity and same radius, so of course Fy is 0, so there is nothing to do on vertical line or y-axis. What causes the box to move in circular path? So we already explained in here in our example what causes the box is moving in circular motion or circular path, but what causes it to move in circular path? So we already described that there must be a force keeping it away from falling towards the direction of that regular velocity that it has. So there must be a force, or there must be something that pulling it towards the center of the circular path, which is called tension. Tension is the key of our answer. Well, in order to answer to this question, first we have to answer what is pushing the box towards the center. As we said, the tension. So the normal force and gravitational force, as I said, they're balancing out, and the only force that is visibly acting on the box and causing it to move in the circular path is tension and friction. As I said, the velocity, which is opposing the circular path. Now, okay, guided practice. I'm just trying to say, as I explained earlier, that if, okay, in here, I'll just go on here. Okay, if the object is moving in circular path, okay, and of course we have tension here, this force is called tension, and then suddenly we cut the rope, we cut the string or rope, and of course at point A, the object will fall probably in this way because the velocity is trying to go against the direction of our tension. So it will probably go in a straight line. So all we can say is that in point A, what is keeping it in circular path is tension, and if we cut this string, it will probably go in this direction, like that. All right.
Okay, right now we're going to talk about the uniform circular motion on a vertical plane. This is only possible when the velocity is constant, the radius does not change, but there's always a change in direction. So let's look at an example. This is me. I'm trying to make this object change in direction but not in the speed. And according to Newton's second law, if there's a resultant force, this object is going to move. So there is a resultant force. If there's a resultant force, there's going to be an acceleration. So we said that we don't want to change the velocity. So that does not, acceleration does not mean always a change in velocity. It could also mean change in direction. So we know there's a force acting downward. We cannot add a force upward because it's going to change the velocity. There's a force perpendicular to the velocity. So let's go a split second into the future. The object will be here. It's gonna have the same velocity. The radius will not be changed, and yeah. So the force always will be towards pointing towards the towards me, and we will keep going like this until it makes a circle, and this will keep continuing. So what makes circular motion possible? This is only possible when the force is acting 90 degrees to the object towards the center of the circle. So if this is a circle and this is the pivot point, all the forces are going to be acting 90 degrees to the pivot point. And like there's examples like satellites, Ferris wheels, there's so many examples we can use. And so right now we're going to talk about the centripetal force. So we know that there is a force acting 90 degrees to the pivot point. So what is this force called? This is the centripetal force. This is the force acting to the center of the circle. And we have derived this equation for angular acceleration. This is derived from force equals to ma, which is the Newton's second law. And we derived this equation, and we can use it to find the centripetal force. So we know that angular acceleration equals to velocity squared over r, and force is mass times acceleration. So we have mass. The acceleration, angular acceleration, is equal to velocity squared over r. So this is the way we can find centripetal force. As you've seen in the video, I've explained how uniform circular motion is valid in vertical planes, and I discussed about how the sublimation of forces on x-axis is 0, and the forces acting on an object on a y-axis are the force of gravity and the normal force of the object. How circular motion coexists with horizontal and vertical planes. So as you see in the diagram, there is a man spinning a ball around an axis, a pivot point. So the tension in the string can be divided into two components: horizontal, which is the centripetal force pulling the ball closer to the center of the circle, and the vertical, which is the tension opposing the gravity. We know now how circular motion coexists in vertical and horizontal planes. So now let's solve a few practice questions. A cyclist who has mass of 48 kg turns a corner with a radius of 30 meters at a speed of 25 meters per second. What is his angular acceleration? We've derived the equation from the Newton's second law, and its angular acceleration equals to v squared over r. We have a velocity given, which is 25 meters per second, and the radius is 30 meters. So we plug it in the equation. 25 squared divided by 30, it equals to 20. So the angular acceleration is 20 meters per second square. Next question is, why does a cyclist lean to one side while going along a curve? In which direction does he lean? While going along a curve, the cyclist leans to one side so as to provide himself the necessary centripetal force. He leans in the inward direction towards closer to the center of the circle. Alright, this is an MCQ question. It says an object of a mass is tied to a string of length L and whirled with speed v in a circular path. Which of this following statement is correct? So you can there are different types of answers for this, but the correct answer is A. Centripetal force is not any kind of force. It is just force. We require centripetal force for circular motion, but it comes from force exerting on the object only. So only tension and weight are the forces acting on the object. We are done with the sample problems, and we've discussed about how what acceleration is, how circular motion is there in vertical